Friends, now we are going to discuss about firmware-based projects, means programs, projects using microcontrollers, something like that. So we are going to discuss about microcontroller-based projects. So microcontroller-based projects are called embedded projects and generally consist of the following part. The first one is the hardware, second one is the firmware. So hardware is nothing but the IC, the circuit diagram, everything. The firmware is the software which actually gives life to the hardware. Okay, the first step in designing a microcontroller based project is to select a proper IC. Which type of IC you have to select? Which type of IC means the microcontroller. So how to select a microcontroller? The attribute that you have to trade off between are number of pins, cost, availability of internal memory, ease of program, etc. So in order to get a brief description of various microcontrollers that are available for project designers, you go to my blog jagadishelectron.blogspot.in. Just copying it down. Okay, so this is my blog. Okay, just copy it. Okay, well, you go for microcontrolling program methods in embedded systems. On this one. Okay, differences between 8051 PIC and AVR. So differences between the various families. So 8051 is for students, PIC and AVR are also for students based project, but AVR is also used in industry. And after this, learning these three microcontrollers, means how to program them, the next one is ARM based processor, which is used extensively in industry. So we have three families: 8051 family, this is a quite oldest family and best one to start with, and it is also quite easier, oldest and simplest controller to start with. And then we have the PIC family, intermediate to 8051 and AVR, it is better than 8051. Then finally we have the AVR family, most advanced processor for hobbies and projects. And ARM family, these are the highest high-end processor used in missile, space, aeroplanes, etc. So I am not going to discuss about ARM family. So these processors are also a bit costly. Now what are the different attributes? First of all, cost. Okay, so we are comparing the three things: 8051 family, PIC family, and AVR family. So out of this, which one is the best one? So there are different attributes: cost, programming software that are used, burner software, burner hardware, power architecture, how many bits, uh, OS. Okay, and date of when they when was the time they were first manufactured, instructions, what are the different instructions, what are the number of instructions, clocks per instructions, what is the crystal oscillator required. Okay, there are different other issues. First one is cost. It's 8051 available for a cost of 80 rupees, PIC for a cost of 170, and Atmega for a cost of 220 to 300 rupees. Atmega 8 is a bit low cost, Atmega 32 is a bit a higher cost. The programming software used is Keil software, MPLAB IDE, WinAVR. Now MPLAB IDE and WinAVR, these are free version softwares, but these are a bit difficult to learn. But Keil is a free version software, but it's not a free version, it's a licensed software. You may have to buy a license in order to take full advantage of Keil. But Win8051 is a free software. Other softwares are also available. Now the burner software, once you design once you get the hex code using these programming softwares, you get a hex code, right? And then using the burner software, you have to burn it into your microcontroller. So you have ISP, parallel port, flash magic, serial port, burner, and extreme burner. Various other burners or softwares are also available. For PIC, you have MPLAB ID, WinAVR. No other variations are available for these two. Burner hardware. Okay, burner hardware is something that you have to invest. If you design for 8051, the cost of the burner software is going to come around 40 to 60 rupees. Professional burner tools cost in market from around 1000 onwards. So which one is better? Buy it in market, or you design it yourself? I think when you design it yourself, you get some experience, and it's also very cheap. So it comes around 40 to 60 rupees. So better to design a burner of your own. Okay, professional burner tools come for around 1000 rupees. MPLAB home home developable AVR burners are also can be designed. These come around 40 to 60 rupees. USB ISP programmer, this can be bought from shops, various shops. Okay, power. 8051 consumes power of 5 volts, PIC 5 to 4 volts, whereas AVR from 5 to 3 volts. Architecture, this is CISC, and these two are reduced instruction set computers. This is 8-bit. All these microcontrollers are 8-bit controllers. Uh, so date of birth, this was designed in 1985, and after 8051 was developed, PIC were developed. These are the latest versions of microcontroller, and instructions of 8051 are around 100 to 240, and instructions of PIC and AV are around 40, because they used RISC architecture, so reduced instruction set computers. Clocks per instruction, here you have 12 clocks per instruction, here you have 4 clocks per instruction, here you have 1 clock per instruction. So best one is AVR, it works very fastly. For 12 megahertz crystal, one if the speed is 1 amperes, here you have 3 amperes, and here you have 12 amperes. So the fastest one is AVR. So always it is better to go for AVR controller. Programming, from programming point of view, easiest to code, add the various commands are easily available, whereas PIC is a bit difficult, most difficult, add, some mult, and lot of such commands are not available. Hardware complex, simplest hardware. Complex hardware with online on chip peripherals like SPI, ADC, USRT, etc. Next, complex hardware with various other type things like serial program interface, ADC, I2C, USART, analog comparator, internal LC, etc. A bit complex, but it has a number of functionalities. Manufacturers, 8051 is designed by around 50 companies. Atmel, Motorola, different companies manufacture 8051 IC, whereas only Microchip designs PIC controllers, and only Atmel designs AVR controllers. Software support, no free software support from company. Keil provides the software. So now free software support from Microchip. Okay, the chip designer only provides a free software. Free software support from Atmel and Win AVR. Okay, the chip designer provide a free software for Atmel and AVR. So here you have instruction restriction of software. Speed, this is the faster, fastest. Memory is small, you have small on chip memory, large on chip memory, you have flexible on chip memory, different chips like Atmel 8 comes with 8 KB of memory, Atmel 16 comes with 16 KB of memory, Atmel 32 comes with 32 KB of memory. So analog to digital converter, here you do not have any analog to digital converter, you have to use an external ADC converter. Here you have an inbuilt analog to digital converter, and here also you have inbuilt analog to digital converter. Timers, here you, in all the three you have an inbuilt timer. Software emulation, unregistered keil can program up to 2 KB. Okay, but Win 8051 has no such limitation, but it is purely assembly based. If you have to use this software, you have to write the program in assembly language. So how to use it, if you want to learn how to use it, then you can go to website website on IIT tutorials, where, okay, I'll show you some other time. You can go to IIT Kharagpur NPTEL lectures. There you can learn how to design write programs using Win 8051. So here you do not have any software limitation. Here you do not have any software limitation. So internal memory limitation, 8089S52 has inbuilt memory of 8 KB, but using keil you can program up to 2 KB. Here you have 8 KB to 4 KB to 8 KB of internal memory, depends on the IC number. Atmega 8 provides 8 KB, 16 KB, 32 KB, 48 provides 48 KB, etc. Which one to learn? Best for beginners. So 8051 is best for beginners, difficult and not necessary to learn, as AVR has more advantages. So PIC is no more used. So best to learn, but it is a bit difficult. So that is all about 8051 PIC and AVR controllers. Okay. So which one you have to choose based on the number of attributes. Okay, you have to select the best microcontroller. That's it. Well, hello everyone. In this video, I'll be telling you how to design firmware-based projects. Firmware projects means are those projects which include both hardware and software. Example projects using 8051, microcontrollers, etc., and AVR controllers, etc. Right? So, in order to create a firmware project, you must have knowledge on two softwares. One is the keil software, which is used to program 8051 microcontrollers, and after keil you have one more thing that you have to learn is Proteus software. First of all, like, create a folder on the desktop or make a folder. It's like 80 first, right? I open this folder. Okay, now I open keil. uh, it's a licensed software, but uh, in the unlicensed version you can manage programs up to 2 KB. Okay, first of all, open keil, go to project, close project, then again go to file, uh, sorry, again go to project, new project, go to desktop, select the folder. Okay, now write the name of the project, uh, Z805, something like this. Okay, select the microcontroller that you're using. I am using a Atmel microprocessor microcontroller, so 8089S52. I'm so going for 8089S52. Okay, here I got it. Well, okay, okay. Now here it is added. Now go to new, go to file, save as a kbar name. Okay, dot c. This is the C file in which I'm going to write the program. Well, here you can see akbar.c. Now here I am going to add it. Not here, source group, add files, akbar. So okay, so here it is linked akbar.c. Now I'll write the program. Now this is the program I have written. Go to debug. Before going to debug, okay, first of all go to debug. Stop. Okay, evaluation. This is the evaluation version software. That is why you have the limit of 2K only. So cannot. So now I have to diagnose the problem. Okay. Okay. Why? Because first of all, sorry. Now after writing this project, I go for project and then press build target. It actually shows compiles up, shows what are the errors. So here I have an error while one semicolon everything is there. Okay, here I didn't give a semicolon, right? Okay, now go to project and press build target. Well, so here you have 0 errors, 0 1. It means the project is going to run successfully. Go to debug, start debugging section, and so here you have evaluation version. Code limit is 2K. Since this is an evaluation version, you have 2K code limitation. Now go for run, peripherals, IO ports, port 1. Now you can see that port 1 is blinking, right? Okay. So that was all about how to program 8051. Now see, so here you have a reg51.h. So under akbar.c you have reg51.h. It shows you a number of details. Well, okay. Now one more thing that I did not do is mm, options for group. Sorry, not this one. Right click on target. Options for target one. Okay. Here the crystal oscillator frequency must be 11 megahertz. So I'm pressing OK. And again option for target one. Okay, this one is 11 megahertz. Everything is okay. Output. I need a hex file. This means the machine code. I need the machine code. That is the hex file that I am going to dump into my microcontroller. Okay. Now I go to project, build target. I to work fine, debug, start section. Okay. Again, run. See how the port 1 is blinking. I go to peripherals, port 2. Port 2 does not blink. Well, that was all about. If you want, you can also increase the loops in order to increase the delay. Now I go to Proteus software. Proteus, run. File, new project. Okay, I give the name of the project as 80. Test 80. Browse desktop 80 first. That's okay. I'm going to new project A1. Next, create PCB layout. If you want, you can do it. Next, so this is a firmware project. I said you, it includes both hardware and software. Okay, so select create firmware project. Select the IC. Our IC is 8051 family microcontroller 8089. S5 is not available, so we go to 8089C. 8089C 51 is there. Okay, this is also going to work fine. Next, finish. Well, close it. So here you have the microcontroller. So now when I press run, you have warnings. The warning shows that no program code is loaded. So now I have to load a program code. So initially I designed it using Keil software. This was what I have designed. This was the program. So where is it present on the desktop? I'm going to show you that on the desktop this is the folder, and okay, here you have something called a hex file. Okay, so this is the machine code that I'm going to dump in the microcontroller. So how I'm going to dump is just double click it. So okay, so in over the desktop you have something called 80 and here you have hex. This is the machine code. Okay, now I'm going to run the program. So here you can find that there are no warnings. Okay, you can see that how the output is blinking. So here there are no warnings. And one thing now you can ask me, there is here you have there is no crystal oscillator, how it actually works. Okay, there is no other circuits are also not present, the power supply, everything. So by default, the Proteus software does not cares about all these things. It only cares about the program. But whenever you have to implement it, you have to connect the crystal oscillator here, and some other circuits must also be connected. Well, so you want to increase the delay. Okay, so just see how the LEDs are blinking. Output is changing. Now let us increase the delay time by 1000. Well, I go for build project project build. That's it. Now let us run the program again. Now you can see that the delay time has varied considerably. Now if you want, I can also connect a LED. Electronics, some LED. Green LED. Let's take some LED. Okay, this is how LED is blinking. So this is how to use. So now till now I have said you how to use the Proteus software, how to design a firmware project, how to use keil software. Well, so this was the simulation part. Only in simulation, how to simulate it in a computer. Now in real world, how we actually do it. So I'll show you in the next video. Okay, so there are a number of ways by which we can burn a hex code or a machine code to a microcontroller. Uh, there are costly techniques, there are also cheaper techniques. The one that I have used is a quite cheap technique. It takes around 100 rupees, something like that. So you mainly need a parallel port 25 pin D connector. This is the circuit diagram I am showing you. I have copied it from the internet. Sorry, I did not acknowledge the author even. Okay, whoever is the author, I am very thankful to him. Okay, so these are the different pins. EA pin is connected to 105 volts. It generally takes around 80 to 100 rupees to design the circuit. Here you have a crystal oscillator. Frequency is 11.059. This is a 25 pin D connector, and this is the connection diagram for the loader circuit. So using this circuit, you can load any programs to 8051. Okay, this is fixed. It can work for 88NS 51, 52, 88NS family of microprocessors. I did it and it worked fine. So copy this circuit. Okay, now you have a program called as ISP. So ISP, in service programmable. The full form of ISP means in service programmable. Okay, this is used to program 8051 type of microcontrollers. Okay, first of all, you have an option here. So here you have to select the type of the microcontroller that you are using. Okay, so the parallel port that I showed you earlier, this parallel port is actually connected to the computer. Okay, and this ISP program works in Windows XP only and older versions. Okay, now First of all, okay, now this is a list of the microcontrollers that ISP, this flash programmer, supports. Now select the device, go for signature. If everything is fine, all the collections are okay, then you get signatures like this. Just now you saw the signatures. Okay, well, now go to open file. Here the tab is open file. Just a minute. So out of a number of ways that are used to burn a hex code into microcontroller, there are a number of ways. There are costly techniques and cheaper techniques also, but the one I'm going to use is a very cheap technique. This is the IS circuit diagram of ISP loader. This is a 25 pin T connector. Make the connection diagrams as shown here. This is pin number 1, 2, 3 up to pin number 13 and 14, 15, 16, 17 up to 25. Okay, this circuit is going to work fine. It is connected to plus 5 volts, and this is the EA ALE PSEN pin. This EA pin is the connection diagram is as shown here. Okay, well, copy this circuit diagram. Now connect this parallel port to a computer, and after connecting it, okay, after connecting it to a parallel port, actually parallel ports are present in uh, desktops. So if you want to use this in a laptop, you want to burn a program using a laptop, you have to use USB to parallel port converters, right? Okay, first of all, connect yeah, as I said, you have to design a circuit like this. Connect this 25 pin D connected to a parallel port, and then use ISP programmer. ISP means in service flash programmer. It is used to burn programs into flash of 8051 IC. First of all, here you have to select the device. Select the device, go for signatures. If everything is fine, then you get a message like this that everything is good, fine. Well, now what you have to do is you have to open the file location. Okay, now open the file location. Okay, now this is the hex code. This hex code I am going to burn into the microcontroller. Okay. Okay, now go for right, this right option. The moment you press right, program gets burnt into the microcontroller. So how it actually looks like. Open. Okay, so the moment I'm burning it, so this is my kit, actual the burner kit that I showed you right now, the circuit diagram. That is the burner kit that I have designed, and this is the parallel port. Okay. So the moment it is burning, this LED actually blinks. See, it means the writing process is going on. Right? Well, now the program is burnt, right? So that was all about how to burn or dump a program into 8051 using very cheap techniques. In earlier videos, we discussed how to use keil software, how to design firmware for based projects and simulations using Proteus software, and we also learned how to implement it by burning the hex code or the machine code into a microcontroller. Now, uh, what are the different projects, and what is the scope. So you learn so much how different projects can be done. Just this is a small review I'm going to show you. Okay. This is one project that I have developed. First I have tested this project in Proteus software, and then I have implemented it. It worked fine. So this is the microcontroller kit, and here this is a keypad I have interfaced, and this is the display of LEDs. So just run it. The moment I press the various switches, you can see how the output is changing. Well, okay. So actually the first 8 pins. Well, this is one project. Another project. This is a display, 16x2 display that I have designed using 8051 microcontroller. So you can display anything. I'll show you the programs in next videos. So this is how different projects can be done using 8051 using Proteus software and Keil software. So stay tuned for other videos. Okay, since I have shown you that any firmware project that is going to work fine in Proteus and Keil is also going to work fine when it is implemented in real time. So I don't think that all the programs that I am going to show you and the project that are going to show you, I need not show them in real world. Like I'm burning it, like the program is burned to the microcontroller and it works or not. I'm not going to show you all that thing, but the thing is damn sure that if it's going to work fine in Proteus software, it is going to work fine. You can implement that project as a hardwired project, right? So now different projects that I have done are, first one is thinking of LEDs. This project I have already shown you, but once again I'm showing you that project. Okay, here is the project. Okay, so whenever you design a microcontroller based project, okay, on the board, hardwired board, then okay, this is a crystal oscillator 11.05 megahertz. Here you must connect to capacitors 33 pf 33 pf. Okay, the circuit diagram must be somewhat like this. Okay, so I have already loaded the hex code. If you want to note the program, this is the program, complete program. Make a note of it if you want to run it. And I have designed the hex code as I have described earlier. Okay, let us run the program. You can see that the output is changing. Port 1's output is changing. Okay, now I am stopping the program. Okay, this 1k and converting it to some 10 ohms, something like that. Now let us run the program. See, this is the LED blinks. Okay, that was the first program, that is blinking of LEDs. Now the next program is now going to the next program, that is display, 16x2 display. 16x2 display. We are going to discuss about keyboard interface. Closing this one. Okay, the program for interfacing keyboard is something like this. Just make a quick note of it. Slowly I'm scrolling it down. Well, okay, and then I have to load the hex code here. Now when I run the program, when I press button number 7, you can see the changes here. Button number 8, button number 9. Red implies that this pin is high. Blue indicates the pin is low. 4, 5, 6, 7. When I press 1, okay, this pin gets highlighted. 2, 3. That's all about interfacing keyboards. Well, I have also shown you the hardware for this project. Now I am closing it. Now let's open a new project. 16:2 display. How to interface a 16:2 display. We have already discussed about interfacing 16:2 displays in earlier videos. What is the protocols, how to send data to command window and everything. But here I am showing you the only the program. Okay. Uh, First of all, I am going to run the program, and then okay, here you have a display called something called Reese Society displays Reese Society, something like that. Now, how the program has been designed. This is the program. Make a note of it. Okay, slowly and scrolling down. Just make a note of it. Now the next project is on IC5. Okay, this is the PCB layout that I have created. Okay, now let us run this program. You can see that the blue LED is blinking. This is a stable multivariate that we have designed. Well, let us stop it. Okay. If you want to see the waveform, then what you have to do is connect an oscilloscope. Okay, so here the output you're getting a square wave. Well, the next project is a number display. Well, I'm running the project. The software code is something like this. This has been implemented using. So this is the keil C program. Once again, you can running it 0, 1, 2. This is a 7-segment display. Sorry, 8-segment display. That's it. So the next project is how to interface a real-time clock to a microcontroller and display the timing. So there is a IC called as DS1307 called as real-time clock. Okay, generally in most of the desktops you might be seeing that a desktop can maintain its time for around 6 years, 10 years, something like that. So how is it possible? So there is something called as a real-time clock. Okay, this is available in the market, or you can design it yourself. Okay, this is real-time clock. Okay, this one I have purchased from the market. It's called as a real-time clock. Well, so here you generally put a button battery. Okay, then it's going to store time at least for 6 months, something like 6 years, not months. It's going to store time for at least 6 years, more than 6 years. This is a real-time clock. So how to interface this to a microcontroller? So generally, a real-time clock uses I2C protocol. Okay, I'm not going to describe you everything, but I can show you the program. Okay, see. So this is the day, this is the date, and this is the time. Now, if you want to see the program. Okay, here is the program. Make a note of it. It's quite a lengthy program. Okay, slowly I'm scrolling down. Just make a note of it. Well, so that was the program. Okay, around 248 lines. Well, so once again I run the program. So here the date, time is generated, the day, and here you get the date. Now this is A to D converter, analog to digital converter. So these are the output pins. You get the output from here, and this is the input. Analog input is given to pin number 6. Okay, here you must a constant clock must be given to W bar and INTR bar pins. Okay, and the rest circuit is, you can see, you can make a note of it. Clear? Just make a note of it. Well, now I run this program. So when I decrease the voltage to 0, you see that the digital output is 0. When I slowly increase to some higher value, you can see that the output is increasing. The digital output is increasing. When I completely increase it, you get all ones. When I keep it exactly at the middle, you get something, an intermediate number. So it means that depending upon this voltage what you are getting a digital output. Well, so in this way, here you can also connect LM35 transistor, which is a temperature sensor, and that can be interfaced to this ADC 0804, and you can convert temperature into digital form, and this can be interfaced with a microcontroller to get the readings from LM35 to interpret as a valuable temperature. So in this way, a analog to digital converter can also be used. Well, so I have already discussed about analog to digital converter, real time, keil, how to interface keils, serial port, number display 555, keyboard display, how blinking of LEDs. Okay, so that's it. Now here I am showing you another project where we will learn how to display 16x2 display. So when I run this program, you get the output as check this as crazy hobbyist. Okay. Well, sometimes this project, when it doesn't work, what you have to do is you have to reverse this port. For example, this is the cable, data cable. Just you have to reverse it. I mean, this wire must be interchanged with this wire. This wire must be interchanged with this wire. Okay. So just try it when it doesn't work. Okay. Well, uh, so here the display has just stopped. If you want that continuously it must display something, then what I have to do is I just cut it from here and paste it inside a continuous while loop. I compile it. You have 0 errors, 1 warning. It continuously types. If I decrease the delay timing, like you have okay. If you want to reduce the delay timing and run the program, then it types very fastly. Well, if you don't want to write something continuously like as it is writing here, what you have to do is cut this code, paste it here, go to project, build, now run it. Okay, you want to change the project program and write something like, you can write I okay, so this is the program. So this init code that I have written, it is actually in the initialize the setting of display. This display is used to display something, some character sets, anything on display. This enter is used to go to the next line. This display again is used to display whatever is present here. Okay, and I go to project, build it. Now I'm going to run it. Okay, okay, I love my parents, right? Okay, this is the project. So now I'm going to show you the code, make a copy of it. Slowly I'm going to scroll it down. Please note it. Okay, this clear screen is used to clear the screen completely. For example, if I write here, if I write here clear screen, okay, initially the output was something like this. Okay, I am writing clear in a clear screen here, project. Now let us see. Now let us see the output. So okay, go into project, build. Okay, I love my pets. So did you observe the output? Once again, first of all, I love my, okay, parents comes here. So if I remove clear screen, it works something like this. Okay, now I go to project, build, and now let us see the output. So after removing clear screen, it again worked as earlier, right? If you want to display something continuously, what you can do is copy this code, cut it, and paste it inside the while loop. Here you can write India is great, and the next line India. Now let us run this project target. Sorry, there is a small error somewhere. I have to remove one semicolon. Okay, now go to project, build target. 0 errors, 1 warning. So India is great, India. That's it. This is the last project that I am showing you. So this is a calculator that I have designed. It's not a complete project, but just the idea that you can also design projects like this. See, this is I have running the program now 7 into 6. Okay, into was not multiplication was not pressed properly. The moment I press multiplication, you get a sign here 3. The moment I press equal to, you must get an answer. So it's not a complete project, just a small demonstration. If you want to see the program code written in keil, okay, this is the program code. If you want, you can make a note of it. I'm slowly scrolling it down. Well, that's the end of the program. 157 lines. Closing it right now. Okay, so thank you all for watching my videos. So I demonstrated you how to design various projects using microcontroller. In my next videos, I'll be telling you how to build projects using AVR microcontroller, and I will also be telling you how to build RC aeroplanes and other things. So it may take a few years. Well, okay, thank you everyone for watching my videos.